Hi everyone. I'm Grant Brian M. Africa, and I'm here to present the final requirement for E-Elect 2, which is the mechanical sequence of A plus C plus going to B plus, going to A minus, going to B minus, going to C minus, then loop back. I will now proceed to wire the pneumatics. I will now proceed to write the codes. This is my cylinder A, cylinder B, and cylinder C. We will now start the system. That's all. Thank you.
Here is my mechanical sequence. A plus, C plus, to B plus, to A minus, to B minus, to C minus. In order to actuate B plus, LS2 must be first met. In order to actuate A minus, LS4 must be first met. In order to actuate B minus, LS1 must be first met. And in order to actuate C minus, LS3 must be first met. And in order to make this whole mechanical sequence to loop back, LS5 must be met. R1, R2, R3, R4, R5, R6 are relays. But in the PLC program, R or relays are replaced by memory bits or the letter M in order for the PLC to know or to understand the relay. The next part is my pneumatic circuit. My pneumatic circuit shows that the cylinder A is located in the upper left, cylinder B is located in the upper right, and cylinder C is located below A and B. Here is my PLC I/O list. The first part of the table, X indicates the input, Y indicates the output, and M, as I first said, indicates the relay of the PLC program. XO indicates start, X1 indicates stop, X2 indicates LS1, X3 indicates LS2, X4 indicates LS5, X5 indicates LS4, X6 indicates LS5, X7 indicates LS6. For the outputs, Y0 indicates A plus, Y1 indicates A minus, Y2 indicates B plus, Y3 indicates B minus, Y4 indicates C plus, Y5 indicates C minus, and in the last part, M0 indicates relay 1, M1 indicates relay 2, M2 indicates relay 3, M3 indicates relay 4, M4 indicates relay 5, and M5 indicates relay 6. Here is my PLC wiring diagram. As shown, all the devices are connected to a 24 volts DC supply, and the negative terminal of the 24 volts DC supply is both connected to the COMs of the input and outputs, and the positive is received by each devices in the inputs and outputs. And lastly, this is my PLC ladder diagram. In the first part, as I push the start button, MO is energized. And when MO is energized, A plus and C plus then activates. As the condition is first met, X3 is now closed while MO is now closed, thus starting M1. But as M1 starts, the first condition will now be open, thus de-energizing M0, and M1 will be now energized. And this goes on until M5. And N5 is where my program loops back to the top as shown. When M5 is energized, M4 will now be de-energized since M5 close contact will now be open, and the open contact of M5 at the top will now energize M0, thus starting the loop all over again. And here is where the solenoids are being energized by the use of the different M's. And M indicates memory bit in the PLC ladder diagram.